Hello, hello. Questions. So, motion test coming up. We've got our distance displacement. We've got our speed, velocity, acceleration. We've got our, what else is it on? It's on force diagrams. It's on the graphs that go with it. So we got a lot going on here with F equals ma, the three laws. It's only two standards, but it really covers a lot of material. So make sure that you have gone back to the very beginning. It's been a while since we've done it. So make sure you go all the way back to the beginning to make sure that you remember what we've done this unit, because it's been a while with Thanksgiving and everything. Let's see. Anyone put... Yeah. Let's see. How can you tell? Here's our first question. How can you tell when one is like... When one like is longer... What? Oh, you mean force diagrams? Okay, real quick. Let's see. Pages. Force diagrams. That's what we're looking at real quick. So, real quick, right, you can either have a box or you can have a dot. Either way, you draw your arrows, and the question is how can you tell which one's longer? Well, you can't unless they're labeled. So, like if this is labeled 25, oh my goodness, this is a very large pen. Let's see. Let's try this pen. One's labeled 25, that's better. Newtons. And then this one's labeled 30. Alright, it's too cold in my house. Alright, seriously, pen? Am I gonna have to use my mouse? Then, even though this one looks longer, is labeled, so this one looks longer, but this one's labeled longer. So you go with whatever the label is. If they're not labeled, then it's just on common sense. Is it super long, or is it roughly about the same size? If they're roughly about the same size, then you assume they're the same size, unless they're labeled. One might be labeled 23, one might be labeled 25, and you just go by that. All right, I have the study guide up. Is that something you guys want me just to work through? It doesn't really look like you have put questions into the chat. But beyond that, scalar and vector quantity. Good question. Well, that's right up here. What is speed? What is velocity? What is acceleration? So when we talk about scalar and vector quantities, we're talking about things that have magnitude and things that have direction. So scalar, it just has magnitude, meaning it is just a distance, just a number. So speed is 20 miles an hour, 10 meters per second, 30 feet per hour, which would be very slow. But speed is all about that. That is a scalar quantity. You have your measurable from start to finish, how far you went, how fast you're going, so on and so forth. You can measure it. You give it a number. That is the magnitude of it. It's 1, it's 10, it's 100, so on and so forth. A vector quantity, so if speed is scalar, a vector is the scalar plus a direction. So you have magnitude plus direction. So instead of 20 miles per hour, which is the speed, you have 20 miles per hour east. So 20 miles per hour east adds in the direction that you're moving and makes it into a vector quantity, which is then velocity. So the only difference between speed and velocity is one is scalar, one is vector. Speed only deals with magnitude, and velocity only deals with it deals with both magnitude and direction. So when speed is scalar, so that's right. Yes. My tablet's having trouble today. Speed is scalar. It is not a vector. It is the amount of distance traveled over time. Speed's difference over time. So our answer is D. Okay, so it's both A and C. So if you're dealing with velocity, a lot of times we'll say the velocity is, and then we give a speed. Okay, so they're used kind of interchangeably, so it can get a little confusing. But remember, velocity has the added requirement of a direction. So what is velocity? It is a vector quantity, and speed in a given direction. So this one is d as well. Okay, so the only difference between speed and velocity is velocity needs a direction and speed does not. Okay, they both have the magnitude, they both have how fast you're going, how long the arrow is, how big the force is, whatever. A scalar one has the magnitude, a vector has the magnitude plus the direction. And so our third one, what is acceleration? Well, it's the amount of distance covered in over time. That would not be correct. The change in velocity over time, the speed, well, acceleration is not speed, so don't think that. Nope, bad. Change in direction over time, it's actually velocity. You know, you change your velocity by getting faster or going slower. That's your acceleration. So these three questions are pretty straightforward. It literally is vocabulary. If you're having trouble with vocabulary, you just have to drill it. What is scalar? Scalar has magnitude. What is a vector? Vector has magnitude and direction, so on and so forth. You just got to drill it. All right. So do you want me to keep going through? Do you want me to... I hit the wrong button. Do you want me to answer questions as they come or just go through the study guide? I think I'll just go through the study guide. Yeah, it's a January meme. You guys are almost a year old. Good Lord. Okay. Learning target. I can plan and carry out an investigation to analyze the motion of an object using speed, velocity, and acceleration calculations. So what this is saying is basically you can use what you know about velocity and acceleration to be able to look into how something is moving. That's literally all it is. Okay, how something is moving based on the speed, velocity, acceleration. So it's not too crazy. What is the average velocity during the first 5 seconds? Well, first off, when you're given a graph, I've gone through this. Let me walk you through how I do test taking again. Okay. So when you... Okay, can we not talk about Sword Art Online? Like, good lord. This is not an anime stream. It's not an anime stream. Go away. Okay. When you're given a graph, okay, I suppose I can't point at my screen. You don't really know my screen if I point at it. So here you can see this though. When you're given a graph, okay, you have distance, time. You always look at your axes first. Distance, time. So this is a distance over time graph. You know that for a distance over time graph, the slope is your velocity, and how you move is your distance. Okay, so velocity is distance over time, change in distance over time, and your graph shows your change in distance, so your slope is your velocity. Okay, what is the average velocity in the first 5 seconds? Well, we 1 all the way to 5. We go up. 5 is over here at 10. Okay, so we have 10. Maybe my pen will actually work. 10. Change in distance. Now we look at the change in time. It was from 0 to 5 seconds, so that is 5 seconds. All right. Just pretend this is a 5. Apparently I can't write tonight. Whatever. Going to the mouse. 5. Beautiful. I'll write with a mouse. 10 divided by 5. If you need a calculator for that, you should feel ashamed. That is 2. 2 meters per second. That's your answer. Okay? That's all you do. You just find the slope. You do change in distance. So you started at 0, went to 10. You do change in time. You started at 0, went to 5. 10 divided by 5 gives you 2 meters per second. Meters second. You're dividing meters over second, so that makes sense. Meters per second. Okay? So then you have, what point is Bob accelerating? Now, theoretically, acceleration is not shown on a distance and time graph. Okay, we have distance, we have time, our slope gives us our velocity. Theoretically, there is no acceleration on this map, except if you know what acceleration is, then you can infer based on other things on the graph. If you know acceleration, the definition of acceleration is change in velocity over time. So change in velocity over time is your acceleration. We know our slope is our velocity, so we're looking for a slope that changes. Here we have our slope is 2. It's 2 the entire way, therefore it's not changing. It's a constant slope of 2. Here we have our slope that is a straight line. Anytime it's a straight line, your slope is not changing. Okay? Anytime there's a straight line on a graph, the slope is constant. So this is a straight line, this down is a straight line, this one across is a straight line, this one up is a straight line. All of these have constant slope. Okay? Here, the slope curves, the line curves. For a line to curve, you need to have changing in your slope. Okay? So when you have changing in your slope, and we know slope is velocity, and we know velocity is therefore changing, if acceleration is your change in velocity, you can infer that the change in velocity is acceleration, because it is. So section E right here has a curved line. Its slope is changing, therefore we know that it is having acceleration. And acceleration is going down, so it would theoretically be negative. So you can also call it deceleration. But deceleration is acceleration just in the opposite direction. It's slowing down, okay? And that's what this is. It's accelerating down, negative, slowing down, or we can call it deceleration, okay? And then this is E. So we find the section that it goes to. It's 15 and higher. So 0 to 5, 5 to 8, 13, 15, 15 to 18. That's our answer. Okay? Cool beans. So then the graph that looks very similar to distance and time is our velocity and time graph. Okay. So our velocity time graph looks a lot like the distance and time graph, but it's different. Okay. Velocity and time graph, we have our velocity changing over time, and we know change in velocity over time is acceleration. So our slope on this graph is acceleration. So we have velocity, time, slope, acceleration. When you go across, okay, we have constant acceleration on straight lines. When you go across like this, there's no change in velocity, therefore there's no acceleration. Here we have a constant acceleration down or deceleration, and here we have, again, no change in velocity, therefore there is no acceleration. Okay, I suppose I have a, look at this. Oh my gosh, technology, I got a laser pointer. Okay, so what's the acceleration between 10 and 12 seconds? Well, you look here, 8, 12, in the middle must be 10. Okay, you look up, 10, and you go over, that's an 8. Okay, so we know that here we're going to put an 8. And here we go down to 4. Okay, seriously, pen? Giving up on the pen entirely. So we had 8 to 4. That gives us 4 over our change in time, which was 10 to 12. Okay, so 10, 12. I have these mixed up, but you get the point. Okay, this is 4 over 2, which is negative because we're going down. This is supposed to be 4 minus 8. I wrote them wrong, I'm sorry. Negative 4 over 2, which gives us negative 2. And meters per second divided by seconds gives us negative 2 meters per second per second. So our answer is A. Okay. All right. You guys are having way too much fun in the chat. All right, how did you get 8 minus 4? Well, I messed up. It's supposed to be 4 minus 8, and I'll show you. I wrote these backwards. When you are looking at finding the slope and acceleration, velocity, time, the slope is the acceleration, so that's what we're looking for. When you're looking at finding the slope, you have the equation x2 or y2 minus y1 I'm not even going to try because I can't write today, apparently. Okay, y2 minus y1 over x2 minus x1 is equal to your slope. So here we have our y1, which is 8, our y2, which is 4. So 4 minus 8 gives us negative 4. 4 minus 8 gives us negative 4. And then our time was 12 for our second one and 10 for our first one. We started at 10, went to 12. So that's 12. I'm writing with a mouse because my pen isn't working. So just, use your imagination. 12 minus 10 is equal to 2. So 4 minus 8 is negative 4. 12 minus 10 is 2. So you simplify that down, you get negative 2. You also know it's negative because it's going down. Okay, common sense. The slope is going down, therefore it is negative. Okay, so this is the only negative answer, so therefore it can be the only answer that's correct. Okay. Next question, at which point is the speed constant? This is velocity. We can use it interchangeably with speed, remember, because speed and velocity are the same, except velocity has a distance, or a direction. Velocity has a direction, speed does not, otherwise they're the same thing. So velocity constant, here we have velocity going from 0 to 8, so that's changing. Here we have it going from 8 to 8. Well, that is constant. So from 4 to 10 from 2 to 10, it's constant. So here we have 0 to 2, no. 4 to 10, well, 4 to 10, that's constant, so that's the answer. Okay, if you look from 10 to 12, it's not constant, we just calculated that up here. And 0 to 16, well, it definitely moves all over the place from 0 to 16, so it's definitely not that answer. Okay. Okay, cool. Ready to move on? Moving on. Oh, that's the end of the page. Next page. All right, next learning target. I can use mathematical formulas to evaluate the relationship between speed, velocity, and acceleration. So basically, can you calculate speed, velocity, and acceleration? So what are the formulas for speed, velocity, and acceleration is what we're looking at here. Okay. So speed, velocity, acceleration, let's break them down. Speed is change in distance over time. Velocity is change in displacement over time. And remember, the only difference between distance and displacement is direction. And then acceleration is change in velocity over time. Okay, cool. So John runs 12 meters, or I can't read, 120 meters in 10 seconds. What is his speed? So his change in distance was 120 meters. His time was 10 seconds. So you do 120 divided by 10. When you do 120 divided by 10, you move the decimal over. You get 12 meters divided by seconds. Meters divided by seconds. There you go. Your units match. You're good to go. Okay. Here we have a bus traveling eastwards. Here, key point, eastwards. This is where our vector quantities come into play. This is a direction. Now, when you are given a direction, you have to make sure that you match the directions, okay? Eastwards, eastwards, okay? A bus traveling eastwards. That's going this way. Bus going this way. There it goes. Okay, so here's the bus. Beep, beep. Okay, it is at 60 meters per second. 60 meters per second. I'm giving up. Why do I keep grabbing the stylus? The tablet is not working. Okay, 60 meters per second. Okay, it's going east. It is then stopping. When you are going 60 meters per second and you stop, your velocity when you stop is 0. Anytime it says from rest or to a stop, it means from 0. So 60 minus 0, that's easy. 60 meters per second, 60 is your velocity. 10 seconds to stop, that's your time. To find the acceleration, you do velocity over time. So it stops 60 and it goes over 10. 60 divided by 10 gives you 6. If you couldn't do that math, well, all of these are 6. So obviously the answer is going to be 6. Okay, so test taking skills. When all of the answers are the same, you look for the small differences. Okay, look for the small differences. These, all of them say east. Okay, so the direction the bus is traveling is eastward. The direction of the acceleration is also going to be eastward. Here's where common sense comes into play. This is test taking skills, critical thinking, problem solving. When you are looking at a bus going east and it has to come to a stop, you cannot push it further in that direction. If you are going east, any force going more east is going to make it go fast. It's not going to stop it. Okay? So to stop the bus, you must go the opposite direction. You must go this way. Okay? So if we're going eastward here, and to stop, we have to go the opposite direction. Mathematically, to show the opposite direction is a negative sign. So this has a negative sign, this has a negative sign. Therefore, we know for a fact this one is gone, and this one is gone. We are left with these two negative signs going east, so because it is going to stop the bus. Okay? When you look at negative 6 meters per second squared versus negative 6 meters per second eastward, these are all the same. The only difference is the meters per second squared versus meters per second. This is when I wish I could write with my pen. Okay, so acceleration, velocity over time. The units for velocity we know are meters per second. If you divide that by time, which is another second, here we go, meters per second, second. Meters per second divided by second. Okay, you can write that again as meters per second per second. Okay? Meters per second only has 1 second here. Meters per second squared has 2. It must be the one that has 2 seconds in it. Meters per second second or meters per second squared. That's the same thing. Okay? So, your answer is D. There you go. I love how we're so concerned with finding out whose username is who. I'm glad that's the focus of the stream, guys. Okay. Why is it negative? It's negative because the direction. A bus is traveling east. Okay? Key point. Bus, bus. East, east. Anything that is still going east is going to make the bus go faster. The bus is not going faster. It says it is coming to a stop. So since it is coming to a stop, you must have a force going the opposite direction. Okay? So if it's going the opposite direction, then it's a negative. Okay? If it's going this way, then it's a negative. Now, if this said westward, wouldn't that be opposite already? And we wouldn't need the negative. But since it says eastward, we have to have the negative because it is going the opposite direction. Okay, so that's how you know when to negative. It's all about directions. It's a vector quantity. Vectors determine direction. You have to have direction for it to be vector. And here, our eastward and our negative are our directions, making this a vector. Acceleration is change in velocity. Velocity is a vector, therefore acceleration is a vector. Okay, we're moving on. If Wayne is traveling at 6 meters per second for 30 seconds, how far does Wayne travel? Okay, this is simple math. Wayne traveling at a speed, a time, and we're looking for a distance, okay? Well, we know speed is equal to distance over time. This is actually change in distance. Imagine that is a delta. Don't tell anyone. Don't tell anyone. This is a triangle. Close enough. Okay? Speed is equal to change in distance over time. So we are given speed, we are given time. So we rearrange the formula. We're looking for change in distance. Okay, so you move t to the other side. We have distance is equal to time times speed. Okay, you just plug it in. Our time is 30 seconds. Our speed is 6. You do 6 times 30. You find the answer is 180 meters. Boom. Done. Okay. What, Isaiah? You have done something different on that bus question. We're back to the bus question. All right, going back. Back to the bus question. What did you do differently? We'll go back. Jennifer, when it asks for a generic equation is this. Speed equals distance over time. That is a generic equation. So anytime it asks for a generic equation, it's asking for something without the numbers plugged in. Okay, so just a equation. Like distance is equal to time times speed, or time times velocity. Okay? Guys, do not make me shut chat down. Yes, Isaiah, you could have figured this out just by looking at it. That is absolutely true. Because they're all the same one, so all you had to do was know that acceleration must be opposite direction, and then the units would be what the acceleration units are. You could have done it just by looking at it. You are correct. Okay? Next one, learning target. I can create and analyze graphs and free body diagrams for distance, displacement, speed, velocity, time, acceleration, inertia, force pairs. All of these words right here. These words. Distance, displacement, speed, velocity, time, acceleration, inertia, force pairs. You must know every single one of those words. This is vocabulary. Vocabulary is very important for these. Distance means the total distance you travel. Displacement, the distance from the shortest from your start to finish. Okay, so if you finish exactly where you started, your displacement's 0, even though you could have ran 100 miles. Okay, speed, how fast you're going. Velocity, how fast you're going in a direction. Accelerate, or time, the amount of time you take. Acceleration, the change in velocity over time, how fast you speed up or slow down. Okay, inertia, the amount that you resist moving or you resist stopping. Okay, that's measured with mass. The more mass you have, the more inertia you have. Force pairs, two forces going against or with each other. Okay, you must know every single one of those. All right, an upward force of 150 newtons is applied to a box weighing 70 newtons. Which of the following is a free body diagram for the situation? Okay, we'll just work it out. 150 newtons, keyword up. upward. Upward means up. So up. Okay? And you label it 150. Okay? And then weighing 70 newtons. Well, weighing comes from gravity. We know force of gravity goes down. So that's 70 newtons. And there's our diagram. So we look over here, and boom. Same exact thing that we drew right there for D. Okay? Alright. We good with that one? Yes or no? Okay. Two forces act on the 2 kilogram box shown below. Okay, so we have our 2 kilogram box. We is labeled 2 kilograms. A 4 Newton force acts to the right. 4 newtons pointing to the right. 6 Newton force acts to the left. 6 newtons to the left. What is the net force? When it says net force, you add all the forces together and you see who wins the tug of war. If we're pulling 4 to the right, 6 to the left, well, who's going to win? Well, 6 will. It is bigger. Okay, it's going to beat the 4 newtons. How badly is it going to beat it? Well, 6 minus 4 gives you 2 newtons. So our net force would be 2 newtons, and which side wins? Left. So 2 newtons to the right? No. 2 newtons to the left? Yes, that's it. Okay, so net force is all about your force pairs. Who wins the tug of war? Okay, that's all you're looking at. Okay, all right. I hope we can all do tug of war. If you cannot, let me know. We'll do some more. The graph below shows the velocity of a car that is moving in a straight line. We have our velocity and time graph. Therefore, we know things already. We know in a velocity and time graph that when it goes up, it is accelerating because the slope is positive. When it stays in a horizontal line, we know the velocity is not changing. It is a constant speed. If the velocity is not changing and it has a constant speed, your slope is 0, and therefore your acceleration is 0. And then we have it going up and down. When it goes down, your velocity is decreasing, means your acceleration is negative, or you are decelerating. During which of the following intervals are forces on the car balanced? Okay, so we're looking at net forces. When you have balanced forces, okay, you have no acceleration. So F is equal to ma. Okay. When F is 0, your mass is still going to be whatever it is. So let's say 100. Okay, you don't lose mass. So it must be multiplied by 0 so for it to be 0. So if force is 0, acceleration is 0. If acceleration is 0, force is 0. If mass is 0, you don't exist. So that's not ever going to be 0. Okay? So when our forces are balanced, force is 0, our acceleration must be 0. Well, there's only one part on this graph that has a horizontal line with no change in velocity, and that is RS. So that is the only point that has balanced forces. Okay? A balanced force means no acceleration. An unbalanced force means there is acceleration. Okay? So, you guys are so concerned with talking about anime that I can't see any real questions. Okay, I'm moving on. I think we got this so far. The graph below relates speed and time of 4 cars, 1, 2, 3, and 4, traveling along a straight highway. So we have 1, we have car 1 right here, we have car 2 over here, car 3 right here, car 4 right here. Okay, it then asks which 2 cars move with 0 acceleration. Okay, speed, time, that's the same as the velocity time graph. So we know that if there's no change in speed, there's no change in velocity, then we know for a fact that acceleration has to be 0, because acceleration is change in velocity. And if you have no change in velocity, you have no acceleration. Well, this one has a slope, this one has a slope, whereas this one is horizontal, meaning its slope is 0, and this one is horizontal, meaning its slope is 0. So 2 and 3 have 0 slope, meaning they have 0 acceleration, meaning that is the answer, 2 and 3. Okay. Okay, moving on. The graph below shows the distance a student walks down a hall over time. Use the information shown on the graph to answer the following questions. Distance traveled over time, distance, time. Cool. So distance time graph, we know our slope for a distance time graph is velocity. It says during which time interval was the student moving the fastest. If your slope is your velocity is basically the same as speed. Okay, so you're looking here, which one has the biggest slope? Well, this one goes up. You could calculate each one, or you could just look at it. Okay, let's just look at it. A kind of goes up at a diagonal. B is a smaller diagonal, so we know A is bigger than B. C is a straight line, meaning there is no velocity, so it's not moving at all. And then D is a very steep line. It has the steepest slope. It has the greatest slope. Slope is velocity. Therefore, it is moving the fastest at D. Okay? The figure shows a block that's being pulled along the floor. According to the figure, what is the acceleration of the block? Okay, acceleration. We know how to calculate acceleration. We know acceleration is change in velocity over time. Unfortunately, for this problem, there is nothing about velocity and there is nothing about time. So we cannot do it that way. We have to do it a different way. So when we think through about acceleration, we know velocity over time. That's not going to work. So the other thing that we've done that has acceleration is force is equal to mass times acceleration. Here we go. F equals ma. Well, 20 kilograms, that's our m. We're looking for our a, so we can rearrange our formula into a equals f divided by m. Okay, and I just did algebra, just divided both sides by m. Plug in your mass at 20, so A is equal to F over 20. Okay, our force, we got to find our net force. If we're going 50 to the right, 10 to the left, it's a tug of war. Who's going to win? 50 is going to beat 10. How badly is it going to beat it? Well, it's going to beat it by 40 newtons. So our force is 40 newtons. So acceleration is 40 divided by 20. 40 divided by 20 is 2, and this is meters per second squared. That is our acceleration unit. Okay, so 2 meters per second squared. There we go. We use our F equals ma, Newton's second law, to solve for the acceleration. Now you can do this the same way. You can solve for force if you're given mass and acceleration. You can solve for mass if you're giving force and acceleration. It doesn't matter what two of the variables you get, you can use them to solve for the third. Okay, and that is the last one on that page. So questions over this page before we move on. Let me look at chat. Good Lord. Isaiah, you can just ask your question, dude. There will not be a formula sheet. No. They're easy formulas. All right. Page 4. We're getting there. We're getting there. 3 more pages. Next learning target. I can state Newton's 3 laws. Come on, this is memorization. You have to memorize Newton's 3 laws. That's it. Newton's first law says an object at rest stays at rest, an object in motion stays in motion, except for when it's acted upon by an outside force. So you have second law, F equals ma. Third law, for every action there's an equal and opposite reaction. Okay, we need to memorize these. What do I need to understand in order to be successful in this problem? You need to know the three laws. Which situation is explained by Newton's first law? Okay, well, Newton's first law says an object at rest stays at rest, an object in motion stays in motion, unless acted upon by an outside force. This deals with inertia. The more inertia you have, the bigger the outside force has to be to either move you or stop you. Okay, let's see. One of these will describe something keep moving or something keeping at rest. A basketball bounces upward and then it's dropped on the floor. So it's dropped on the floor and then bounces upward. That is not keeping moving. That is changing direction, so on and so forth. That sounds like an equal and opposite reaction. That's third law. That's out. Goodbye. No. Okay. B, you can lift more mass with the same force using a longer lever. That's a simple machine. We haven't even learned that. That's out. C, even though you can stop pedaling your bicycle, you keep moving forward. Well, that sounds a lot like you keep moving. We'll keep that in. D, more fuel is required to accelerate a larger truck than is required to accelerate a smaller truck. Okay. So, which situation is explained by Newton's first law of motion? Okay, even though you stop pedaling your bicycle, you keep moving forward. More fuel is required to accelerate a large truck than is required to accelerate a small car. This is dealing with acceleration, and that is F equals ma. That's the second law. That's out. This one deals with still moving. Inertia, that's your first law. That's your answer. Okay? According to Newton's second law of motion, in which of these situations is the object accelerating? Okay? So, second law of motion, F equals ma. There's got to be an unbalanced force to cause the acceleration. A book on a shelf. Well, here we go. Book on a shelf. A book. Protons and neutrons. Here we go. Okay. Book on a shelf. It is not moving unless I picked it up. Okay. So my protons and neutrons book will not move unless acted upon by an outside force. But it's not moving right now. So that's not it. That's wrong. A rock sitting on the ground. That's the exact same as a book on a shelf. That's out. A helium balloon tied to a lamppost. So, when I think of a balloon tied to a lamppost, I think of it blowing all around. So that sounds like it's accelerating. But really, it's not, because it's tied to the lamppost, so it's not going up. Whereas D, a ball that's been thrown upward. Okay? So, throw a ball upwards. That's me putting a force on it, causing it to go up. It's moving up, changing speeds. That's acceleration. That is the correct answer. F equals ma. I am forcing the ball and throwing it up. Okay? Which situation is an example of Newton's third law? This is third law. This is equal and opposite reaction. Ball in a vacuum container moves in a straight line at a constant velocity. Well, that's no reaction, so that's out. A ball in a vacuum container accelerates when kicked with a great amount of force. Okay, that sounds a lot like F equals ma. That's the second law. We'll keep it, but I don't think it is. A person riding in a forward-moving car continues to move forward when the car stops suddenly. Okay, so the car is moving. All of a sudden, the brakes stop the car, but the brakes don't stop you. You keep going. So if you keep going, the thing that stopped you is your seatbelt. Or if you're not wearing your seatbelt, something in front of you will stop you. Okay, and then will probably stop you forever. Okay, seatbelt stops you because you keep moving. That's inertia. That's the first law. That's out. D, a person in a canoe moves the paddle backwards in the water, and the canoe moves forward in the water. Okay? If you paddle backwards, so you paddle this way, your canoe goes that way. That is an opposite reaction. That's the third law. That's the answer. Boom. Done. Okay? So, the three laws. You got to know them, and you got to be able to apply them. Okay? Okay, moving on. Next one. I can explain Newton's law of motion as it relates to the term inertia. So here we go. Vocabulary. Do you know inertia? Inertia deals with the first law. Object at rest stays at rest. Object in rest stays in motion. Let me try that again. Object at rest stays at rest. Object in motion stays in motion unless acted upon by an outside force. It's a mouthful, but it's easy to understand. A probe traveling through outer space. So this is like a satellite in outer space moving at a constant velocity. Red flag. Constant velocity. If there is constant velocity, that means there is no acceleration. Okay? No acceleration. If there's no acceleration, there's no net force. Okay, which statement applies to the motion of the probe? If there's no outside force, and the first law says it stays at rest or it stays in motion unless acted upon by an outside force, and constant velocity means there's no outside force, and it's moving right now, then it's going to keep moving. Okay, find the one that says keep moving. Probe will undergo constant acceleration. No, bad. Unbalanced force, no, bad. Constant velocity means there's no force. Probe will continue on its current path until an unbalanced force acts on it. Yep, there we go. That's exactly what we're looking for. There's no force. It's going to keep going until something stops it. That something will probably be a black hole or a planet or a star or some sort of gravity. Okay? Force that makes a probe move through space is equal to its mass. No, that's gone too. Goodbye. Okay? An object moving in a straight line at a constant speed. What will happen to the object if no outside force acts on the object? It's moving in a straight line at a constant speed. Red flag. Red flag. Constant speed means no acceleration. No acceleration means no force. If there's no force, it's going to keep doing what it's doing. That's the first law. You keep doing what you're doing. Okay? What will happen to the object if it's moving in a straight line and no outside force? The speed and direction of the object will change. No! Stays the same. Speed and direction of the object will not change. That sounds better. The direction of the object will change. The speed will remain constant. I don't know how. But I don't know how that would be possible. That's out. The speed of the object will change. The direction will remain constant. Okay, but it's not going to slow up or slow down. It's constant speed. If it's constant speed, the speed can't change. That's gone. B. Okay? Even if you don't remember it. Constant speed. Speed change. You can't have constant speed if you're speed changing. Okay, even if you know nothing about this, you can still eliminate that. Okay? Okay, inertia refers to the tendency, we know what inertia is. Okay? Assume that a passenger is riding in a car, and the driver of the car suddenly slams on the brakes. Which of the following best explains why it's a good idea to wear a seatbelt? A, so you don't freaking die. Unfortunately, that's not an answer choice. Okay? A, inertia will keep a passenger moving forward at the same speed as the car before the brakes were applied. B, inertia will cause the speed of the passenger to decrease. Well, nope. Inertia causes you to stay moving. Inertia will cause the speed to increase. Nope. Inertia will cause the passenger at rest inside the car to move towards the back of the car. Okay, but the passenger is not at rest. It is moving with the car. When the car stops, the passenger doesn't stop with the car. Okay, the passenger is going to keep moving because of inertia. Newton's first law, A. Okay. Is that it? It's the end of that page. Questions over this page? Okay, moving on. Page 5. Alright, learning target. I can explain the relationship between force, mass, and acceleration in the second law of motion. F equals ma. Second law, F equals ma. Ignore my bad writing, it's with a mouse. Okay? That's all. Second law means you're using F equals ma for every single one. A force of 5 newtons is required to increase the speed of a box from a rate of 1 meters per second to 3 meters per second within 5 seconds along a level surface? What change would most likely require additional force to produce the same results? Okay, so the same results is the same acceleration. This has an acceleration. It's going from 1 meters per second to 3 meters per second. That is 3 minus 1 is 2. Okay, along 5 seconds, that is 2/5 meters per second squared. That's your acceleration. Okay, you're given acceleration, you're given your force, you know your mass of the box theoretically, okay, and all of this equation works out perfectly. What change would most likely require additional force to produce the same result? So the mass stays the same, the acceleration stays the same, the acceleration stays the same, that's the same result. So A, reduce the mass of the box. This is multiplication. Mass times acceleration. The same result means acceleration stays the same. If acceleration stays the same and mass goes down, you're now multiplying this by a smaller number. You're not going to get the same product that you did. Okay, this is the computational thinking. So we have our mass reducing multiplied by the same acceleration. We will have a smaller force. It says require additional force. That means bigger, not smaller. It's gone. Okay, make the surface of the box smooth. I don't see how that will help anything. So eliminate that one. D, make the surface of the floor smooth. So theoretically, you smooth out the surface of the floor, you put it on ice or something. That means you have less friction. If you have less friction, you don't have to overcome friction. Okay, it's easier to push the box. If it's easier to push the box, that means you need less force, not more force. Therefore, it's gone. Increase the mass of the box is the correct answer. Okay, you have the same acceleration, but if it's a heavier box, to get the same acceleration, you have to push harder. You have to have additional force. Okay, your force must be bigger, so B is the correct answer. Okay. If a force of 26 newtons is exerted on two balls, one with a mass of 0.52 kilograms and the other with a mass of 0.78 kilograms, which ball has the greater acceleration? Okay. F equals ma. Again, F equals ma. Second law, F equals ma, all the time. Force, 26 newtons, that's the same. Mass is different. Which one has the greater acceleration? Okay, rearrange your formula. We're solving for acceleration. So A is equal to F over m. Okay, just divide it. Put A on its own. To get rid of the m, you have to divide both sides. So F divided by m. Here we go, do the math. 26 newtons is your force, so you plug 26 into here. 0.52 kilograms down for your mass, 0.78 kilograms down for your mass, so you do it twice. You have 26 divided by 0.52 and 26 divided by 0.76. Which one is going to give you a greater acceleration? Okay, that's what we're looking for. A. And wow, I cannot write with a mouse. A. Okay, which one's going to give you a bigger acceleration? I already know which one it is. Okay. When you divide by a bigger number, you get a smaller quotient. When you divide by a smaller number, you get a bigger quotient. Okay. The one that has less mass is going to have a greater acceleration. So the one with a mass of 0.52 will have the greatest acceleration. There you go. Okay. A net force F acts on a mass m and produces an acceleration a. Okay, here's your generic equation, whoever was asking about that earlier. Generic equation, F equals ma. There's no numbers, therefore it's generic. You can use it for everything. What acceleration results if a net force 2F acts on a mass 4m? Okay, here's your generic equation. You have F equals ma. Now, if you have 2F, Your force has doubled in size. If you have 4m, your mass has quadrupled in size. What acceleration will result if a net force 2F acts on mass 4m? Well, you just rearrange it. Acceleration is equal to 2F over 4m. Simplify. That's 1 over 2. So A is equal to 1 over 2 half. A divided by 2. Isn't that half? That's the answer. Okay. There you go. Learning target. Oh, looky here again. F equals ma. More of the same. Okay? F equals ma to support Newton's second law of motion. A 1,500 kilogram car increases its speed by 2 meters per second for each second of travel. What is the net force acting on the car? So this is our acceleration. This is our mass. F equals ma. You just plug it in. All right. I don't know why I tried that again. Okay, F equals ma. You plug it in. F is equal to 1,500. Why is it so hard to write 5s with a mouse? Someone tell me. Times 2. Well, multiply it. 15 times 2 is 30. You got 2 zeros, so 30 with 2 zeros is 3,000 newtons. There you go, done. Okay. The diagram represents forces acting on a block that accelerates 6 meters per second on a frictionless surface. So there is our acceleration. Okay, what is the mass of the block? Well, F equals ma. Here we go again. There's a theme here, guys. F equals ma. We're looking for mass, so we have to rearrange it. So m is equal to F divided by a. Okay, you rearrange it. So m is equal to our force. Well, we got to find our force. Here we have gravity, we have normal. You know, normal is there to cancel out gravity so you don't fall through whatever you're sitting on. Okay, so those cancel out. Here we have a tug of war, 18 and 6. Which one's going to win the tug of war? 18 pulling this way or 6 pulling this way? Well, 18's bigger. How much bigger? 12. It's 12 newtons bigger. Okay, so that's your net force. We are given the acceleration at 6 meters per second squared. Okay, 12 divided by 6, well, that's 2. Okay, 2 kilograms, that's your mass. There we go. Okay, last one on this page. The diagram shows an object being pushed along a frictionless surface, so we don't care about friction. The object accelerates at 2 meters per second, so that's our acceleration. We're given our mass. What force was applied? We have F equals ma. Plug it in. m, 3. Acceleration was given to us at 2. What's 3 times 2? Well, it's 6. Boom. Done. Hopefully the math is always this easy. It might not be. But hopefully these numbers are always 3 times 2. Man. Easy. Alright, questions on this page. Let's see. Everyone asking about the FET. You know you can turn FETs in late, but it's stupid to. We have a test tomorrow. Why would you not try to learn everything for the test tomorrow? Why would you have delayed? So yes, you can turn it in. It will be late, but you can turn it in. Alright, if you increase mass and exert force on the mass of a skateboard, will the mass, no matter how high, always get to a certain speed, but it would just take longer to get there? I feel like you forgot about 6 words in that question. If you increase mass and exert force on the mass on a skateboard, So you put the mass on a skateboard. Well, the mass, no matter how high, always get to a certain speed. If you constant have force, if you have the force pushing forever and ever and ever, you will eventually reach the fastest speed of infinity. Okay, because your force will constantly cause an acceleration. It might take a long time, but you'll get to infinity no matter what. It might take millions of years, but you'll get there. Okay, but nothing has a force acting on it to speed it up like that all the time. That's not realistic. Okay, what formulas will be on the test? None. That was it? That was the only question? I think we got one more page. One more page! 3 more questions. How many questions are on the test? More than 1, less than 100. I can apply Newton's 3 laws. Okay, so you got to know each of the 3 laws and able to get on the solve what's happening in the equation. So there's 4 questions here. A person kicks a 4-kilogram door with a 48 Newton force, causing the door to accelerate at 12 meters per second squared. What is the magnitude of the force exerted by the door on the person? So a person kicks the door also kicks the person, and it wants to know what's the magnitude. So how hard does the door kick the person? Okay, Newton's 3rd law says, for every action there is an equal 48 Newton force equal 48 newtons. Okay, equal and opposite. Equal and opposite. 48 Newton force one way, you must have a 48 Newton force the other way. Okay? So they gave you the mass and the acceleration, but you don't care. Okay? All you care about is equal and opposite. Okay? Isabel performed an experiment in which she pulled 10-kilogram mass initially. Let me try again. I forgot a word, I guess. Isabel performed an experiment in which she pulled a 10-kilogram mass initially or at rest. Well, this has got a typo in it. With varying degrees of force for 5-second intervals. The amount of force used in each trial is shown in the data table below. Okay, so she has 3 trials. Trial 1, Trial 2, Trial 3. So she pulled it with different forces. 1, she pulled with 10 newtons. 2, she pulled with 20 newtons. 3, she pulled with 30 newtons. Which statement best explains the difference in the final speeds of mass as it was pushed? So we have our force. We're looking at speed. Speed is determined by acceleration. We have our mass, 10 kilograms. I think we're going to use the trusty old F equals ma formula. Boom. F equals ma. We have our force, we have our mass, we're looking at acceleration, and acceleration, the higher your acceleration, the faster you go. Okay? The final speed of all objects will be equal since the mass did not change. Well, the mass didn't change, that's sure, but the force sure did, and if the force changes, then your acceleration must change, so that is gone. Goodbye. The final speed of all objects will be equal, since force does not affect how fast an object speed up. Force doesn't affect it, F equals ma. Get out of here. Goodbye. C. The final speed of trial 2 will be twice the speed of trial 1 and half the speed of trial 3. Let's look. Okay, we're looking at acceleration. Acceleration is not speed, but acceleration controls speed in the sense that the more acceleration you have, the faster you'll end up going. Okay? So the larger the acceleration, the faster you'll end up going, the more speed you will have. So if A is equal to F over M, again, just doing quick algebra on this equation over here and getting A by itself. So force divided by mass. Our mass is 10 every time. 10 divided by 10 gives me acceleration of 1. 20 divided by 10 gives me an acceleration of 2. 30 divided by 10 gives me an acceleration of 3. So, this is, final speed will be twice the speed of trial 1. Well, it's twice the acceleration. So eventually it might get to twice the speed. Half the speed of trial 3. Well, 2 is not half 3. So let's look at D. The final speed of trial 1 will be half the speed of trial 2 and a third of the speed of trial 3. Well, that math works out. One's half of 2 and one is a third of 3. So there's our answer, D. Okay, F equals MA, rearrange it, plug in, figure out which answer best suits your numbers. Okay? Let's go up here. An object's velocity versus time graph is shown. Velocity, time. What do we know about velocity and time? Well, change of velocity over time is its acceleration. The change in velocity is shown by your slope, so slope is acceleration. During which interval is there no net force acting on the object? Net force is equal to mass times acceleration. Okay? Net force, remember, F net, F, or sigma F. Okay? You can show it either of those 3 ways. During which interval is there no net force? If there's no net force, you either have no mass. Well, if you have no mass, you don't exist, so that won't be it. Or you have no acceleration. We can look at acceleration on this graph. Acceleration is your change in velocity. If velocity doesn't change, you have no acceleration. Well, this section right here has no acceleration. The velocity stays constant. No acceleration means no net force. So that is answer B. And finally, a student bounces a ball on the ground 4 times and records the data of the bounce height as seen in the table below. So we have another table. Bounce 1, 2 meters. Bounce 2, 3 meters. Bounce 3, 1.5 meters. Bounce 4, 3.5 meters. Okay? Which statement about the bounces must be true according to Newton's laws? Okay, so Newton's laws. Object in motion stays in motion. Well, it's bouncing, so that's not quite what we're looking at. 2, F equals ma. We're not given force. We're not given acceleration. We're not even given mass, so it's not that one. Third law. For every action, there's an equal and opposite reaction. That's probably what we're using. Bounce 1, use the least amount of force. Bounce 2, or B, all bounces use an equal amount of force. Okay? If there's an equal and opposite reaction, that means if they all had the same force, they would all bounce to the same height. These do not all bounce to the same height. Therefore, the initial bounce did not have equal amounts of force. Otherwise, their bounce height would be the same, and it's not. So that's out. Okay? Bounce 3 used the greatest amount. Bounce 4 used the greatest amount. So when we look at least, that means it would have the smallest height. 2 is not the smallest height, so that's gone. These both are greatest, okay? So find which one has the greatest bounce height, and that one had the greatest amount of force. 3.5 is the greatest bounce height, so bounce 4 had the greatest one. Bounce 3, bounce 4, that's the one we're looking at. Okay? Answer D. And that's it. That's the study guide. We're done. Questions? Let's see. Will points be taken off if it's late? Obviously. Still better than a 0. Okay, that's the study guide. We are done with it. I will not be uploading this key. Okay, so you're on your own when it comes to that. But if you would like, you can always go back and rewatch this video. Although it is 9:24 at night and you need to go to bed at a reasonable hour, let's say 11. So you got about an hour and a half if you want to keep studying. That's on you. If you have any more specific questions, either over the study guide or something else, you can put them in chat now. I will field them for about the next 5 minutes, and then I will be signing off. So if you have questions, get them in chat now, and I will do my best to answer them. Does this have to do with energy transformation? Not on this test, but yes, it absolutely has to do with energy transformation. But that is from Unit 1, and it is not on this test, but it will be on the final coming up in December. Absolutely, energy transformation and Newton's laws go hand in hand. Absolutely, but it is not on this test. Okay. Can you go back to Ask 8? I don't know what Ask 8 is. So no, I cannot. Explain the third law. Newton's third law. For every action, there is an equal and opposite reaction. If I hit my hand, okay, that means I hit my hand with a force, but this hand also hits this hand with a force. If I punch my microphone, boom. I won't actually do it. That'd probably hurt your ears. Okay? If I punch my microphone, the microphone punches me back. If I hit my table, the table hits me back. For how much? Well, it's equal. Whatever force I hit the table with is the force that hits it back. So that's why you can tap on your table, it won't hurt your hand. You punch the table, it will hurt your hand. You hit it with more force, therefore it hit you back with more force. It is equal and opposite. It hits you back for the same amount of force that you hit it. If you hit a bug on the highway, you're going 30 miles an hour, you hit a bug, that's a lot of force. Well, guess what? That bug hit the windshield back with the same amount of force. Equal and opposite reaction. That is the third law. We have no bedtime. That's probably why you don't pay attention in class. That makes sense. Can you explain the third law? Just did. Can you turn it in tomorrow? I mean, yeah. Can you explain the last question of AKS 8B? Well, isn't this AKS 8B? Isn't this one, the bounce height? The one I literally just did? Is that the one you're talking about? I can explain it again, but make sure that's the one you're asking about. Okay? Otherwise, you got to give me what learning target it is, because there's multiple 8B learning targets. Where are we? Can I take the test Friday? No. We'll see. I don't know. How do you find the mass in the mystery box? F equals ma. You find F, you find A, you solve for M. So if you have F equals ma, generic equation, you just rearrange it. F equals ma, look here. F equals ma, rearrange it for M. You divide both sides by A, so M would equal F over A. Just like A is equal to F over M would equal F over A. You just do algebra on it. Can you explain the difference between velocity and distance over time? You mean the two different graphs? What's the difference of them? Let's find the graphs again. Let's see. Nope, not that one. That one has some, but this is the one. Okay? What's the difference between distance over time and velocity over time? It's what they show. Okay? Distance over time shows just that. It shows distance over time. That's what you're looking at. Distance, how far you travel away. Okay? How far you travel away from your house. That's distance. Okay? How far you come back. That's distance traveled. Okay? Obviously, time keeps going because time waits for no one. Okay? So you have your distance, how far you travel. It's over time. And the distance you travel over your time, change in distance over time, is your velocity. Therefore, the slope of the line is your velocity. Now down here, your velocity is your y-axis. So that's no longer the slope. Now your y-axis is velocity. So velocity over time. So your velocity over time here, if your velocity stays still, that means you're going at the same speed. If your velocity is 8 meters per second, that means you stay going 8 meters per second the whole time. When you change your velocity, we now have change in velocity over time. That's your acceleration. Therefore, your slope is your acceleration. So these two graphs show almost the same thing. They just show distance, and you can calculate your velocity using the slope, or they show velocity, and you can calculate your acceleration using the slope. Okay, so they show almost the same thing, but they are very different when you actually get down into it, and don't confuse yourself, because the slope of these are two different things, because the y-axis are two different things. What else? I have to go in 3 minutes. Goodbye. How many points will be taken off? I don't know, Jocelyn. Just do it. It's better than a 0. Good lord. Can you write Leo? Never mind. I don't know what you mean, Isaiah. Can you explain the 12th Amendment? Isn't that 12th Amendment? Isn't that the Electoral College? Isn't that saying, like, people have to vote for president and vice president in their states? Isn't that what the 12th Amendment is? I don't know. Maybe I'm wrong. There's gonna party on Friday for like 2. What are you even talking? Okay. What's the meaning of life? Probably chocolate. I can explain the relationship. Learning target. Okay, here we go. Learning target. I can explain the relationship between force, mass, and acceleration in Newton's second law of motion. Can you explain the last question in that learning target? Absolutely. Let's find it. Learning target. I can use F equals ma. I can explain the relationship between force, mass, and acceleration. Cool. Last question. Net force. Awesome. Here we go. This is your generic equation that you keep asking about. Okay, a net force acts on mass m and produces acceleration a. Okay, so I'm going to erase this. So, net force. So, net force is F equals ma. Okay, F equals ma. We have our net force, we have a mass, we have our acceleration. Beautiful. What acceleration results if a net force 2F acts on mass 4m? So now we're looking at acceleration. So we can change this formula to A equals F over m. Okay, I just used algebra, got A by itself over there, divided both sides by m, A equals Fm. Now, what acceleration? So A is equal to, the force is now 2F. 2F. The mass is now 4m. 4m. So if this A was F over m, and this A is 2F over 4m, you can simplify this down. This A is equal to now 1F over 2m, right? 1F over 4m. That looks like a half to me, so it's going to be half as big as this one. This is just F over m. This is 1/2 F over m. So it's going to be half as big. So over here, that's 8 times as big. That's out. 4 times as big. That's out. 2 times as big. That's out. A divided by 2. That's half as big. You're dividing by 2. That's taken half. So that's got to be the answer. A divided by 2. This acceleration is going to be 1/2 whatever this acceleration was. A divided by 2. Okay? All right. Will you accept questions about the forces? Absolutely. Yeah, I mean, unless it's like, how do you do this? And then I'll tell you to read the instructions. Will you accept question? Assad, good lord, dude. Quick questions that doesn't have to deal with this. Have you ever watched SAO? I have. It's pretty good. The first season was better than the second. What's the acceleration formula? Change in velocity over time. Or you use F equals ma and you have A is equal to F divided by m. You can use either one depending on what you're given. Change in velocity over time. Oh, thank you, Tenka. Hey, can you draw all equations so I can screenshot and study it? Nope. You got your notes. Will you? Yes, Saad. Chill. I'm not reading chat real time. If you don't have mass, yeah, change in velocity over time. So you look at your velocity, you were going a speed, now you're not going a speed. You slowed down, you sped up, change in velocity over time. That's how you find acceleration. Okay? Okay, I'm leaving. Goodbye. I'm typing in all chats doesn't make me read it any faster, guys. Turn off cruise control. Take off caps lock. I don't have the FET in front of me. You're gonna have to put it in. Just use you're not analyzing the data, Saad. That's all it means. I don't need a paragraph. How do you use the snipping tool? You use it? You just use it? Let's see. See if I can show you this. Alright, on the snipping tool, I can't get it to show you because I've got... No, that's not working. Global sources, add... Window... Snip. Oh, not working. Okay. Never mind. Snipping tool. You open it up. Okay, if you're on Windows, you open up Snipping tool. You go to Mode. You click on Mode. You click Rectangular Snip. Then you click on the New button. Then it will gray out your screen and you draw a rectangle. And then you let go of your mouse and it will take a screenshot of whatever the rectangle was and it will ask you to save it. That's your Snipping tool. That's all you do. Okay. How do you find velocity? I feel like I've answered this 4 times. Velocity. Okay? Change in distance over time. How far did you go? How long did it take you to get there? That's your velocity. So if you went 10 meters in 2 seconds, well, your velocity is 5 meters per second. If you went 10 meters in 3 hours, well, your velocity is, or 10 meters in 2 hours, well, your velocity is 5 meters per hour. You're like a snail. Okay? So, did you want us to answer the question? Yeah, answer the questions. If there are questions in the FET, I want you to answer them. Guys, good lord. Alright. No more questions. 9:38, that's now. Last call. 30 seconds to get your question in. The mystery box. If you're looking for the accelerate or the mass in the mystery box, you got to use your mass thing. Force equals mass times acceleration. F equals ma. That's what you got to use. So you got to find the force. You got to find the acceleration. If you look on the FET, there's different tools that you can measure the velocity. You can measure the speed. You can measure the acceleration, so on and so forth. You got to use them. You got to find the acceleration. You got to find the force. You use that to find the mass. Elijah. Dr. Ellert saying there's going to be a party on Friday after lunch. Cool. Hope I'm invited. Okay. I think that's it. Okay, keep studying. Go to bed at a reasonable hour. It's better to be rested and not studied than to be studied and not rested. Okay? Well, it's super better to be studied and rested. That's the goal. Studied and rested. Not either or. Instead, and. Okay? So there's a tool that you can measure the speed. Okay? And if you start from 0, then whatever your speed is, that's your change in velocity. Okay? Alright. Say goodbye. Goodbye. I'm leaving. Goodbye.